In this lesson, the first lesson of the trig unit, we're just going to review some trigonometry that you learned in grade 10. So in grade 10 you would have started out with right angle trig, which means that you have a right angle triangle. Now we can label the sides of a right angle triangle. Because there are three sides, we have three labels. So the hypotenuse is always opposite the right angle. The adjacent and opposite will depend on the angle. Let's draw it the same way. Will depend on the angle that we're using in the question. So you'll see in this first example that the angle here is indicated by theta. Theta is the symbol for a missing angle. We usually use Greek letters, the Greek alphabet, for angles. And so in this case, if this is the angle that we're using, then the side that is attached to that angle is called the adjacent, and the side that is not attached and is across from that angle is called the opposite. If we switch to this angle, this is still a hypotenuse because it is opposite the right angle, but now this side is attached to the angle. It is next to the angle, so we call that the adjacent, and then this side is not attached to the angle, and it is across from the angle, so we call it opposite. So the opposite and adjacent will switch according to which angle you're using in the question. For example, in here we want to find a missing side. We'll look at the one to the right first. So the first thing you do is you label the sides. And we're only going to label sides that have a measure on them. So this is the angle we are using. The 20 is across from the right angle, so it is the hypotenuse, and the x is attached to the angle, so it is adjacent. We are not labeling opposite because we are not using it, and what we want to do is we want to figure out which ratio we're going to use to solve the question. So we sometimes abbreviate to SOHCAHTOA. SOHCA means sine opposite over hypotenuse, so that's your SOH. Cosine means adjacent over hypotenuse, so that is your CAH. And tan means opposite over adjacent, which is your TOA. So we have the adjacent and the hypotenuse, so we have the A and the H, so we're going to use cosine. So we're going to choose the ratio that will solve the question. So we'll write out cosine theta is adjacent over hypotenuse. Then we're going to fill in the information that we are given. So we are given the angle. The adjacent side is the x and the hypotenuse is 20. And then we are just going to cross multiply to solve. Let's move this up a bit. And so when we cross multiply, we get 1 times x equals 20 cosine 55. Make sure you are in degree mode on your calculator so that you get the right answer. In grade 11 we use degrees. In grade 12 we use what is called radians, which is a different unit. So I'm just going to type in my calculator, making sure that my calculator is in degree mode, and my answer is 11.5. Generally we round sides to the nearest tenth of a degree. There are no units given, so we'll just leave it as 11.5. In the example on the left, let's label the sides that we have. So this is the angle given. The angle opposite the right angle is x, which is the hypotenuse. The 10 is not attached to the angle, so it is the opposite side. If we look at the ratios, O and H are sine. So sine theta is opposite over hypotenuse. Fill in the information given. The angle given 65, the opposite is 10, the hypotenuse is x. Then we will cross multiply. So 1 times 10 is 10, x times sine 65. So in this example you will notice that when we cross multiply, we do not get x by itself like we did in the previous example. So if that is the case, you'll notice that the variable here is on the bottom, whereas here it was on the top. If it's on the bottom and you cross multiply, you're not going to get x by yourself, so you have to divide to isolate. So when the variable is on the bottom, you'll notice that instead of multiplying, you will have to divide. So just be careful of that, because that's a common mistake that students make, is that they always think that they're going to multiply when sometimes they have to divide. So that's 11.0. And then the third type of right angle question you might get is finding a missing angle. So again, it's a right angle triangle, so we'll label the sides. The 8 is opposite, oh sorry, not opposite, it's opposite the right angle, so it's the hypotenuse. And then the 6, you'll see the question mark here, this is the angle we want, so the 6 is attached to that angle, so that is adjacent. So same step, label the sides, choose the ratio. A over h is cosine. Fill in what you know. This time we don't know the angle, we know the adjacent, and we know the hypotenuse. If you want the angle given sides, in the previous example we had sides and an angle. We wanted to find the side. Here we want the angle, so we want to inverse the ratio to get the angle. So we're going to use inverse of cosine. You'll see a -1 as a superscript when you type that in your calculator. You're using the inverse or shift button. So we're doing shift cosine of 6 divided by 8, and we will get the angle. And we're going to divide that angle to the nearest whole number is generally what we do. So it's about 41 degrees. You may need brackets, so just be careful. On my calculator, I had to do shift cosine bracket 6 divided by 8 close bracket. If I didn't use brackets, it would have done inverse cosine of 6 and then divided that answer by 8. So just be careful whether you need brackets or not. Some of the questions might be multi-step, meaning you might have to find 2 calculations or find one before you can find the second. In this question, it wants us to find the length of the slide. So if I look at this slide length, it's part of a right angle triangle, but I only have an angle on that triangle. I don't have a side. I do have a triangle on the left. So this triangle is also a right angle triangle, and I have an angle and a side. So I can use this triangle to find the measure of this side, which is also part of the triangle on the right. So I'm looking for a common side that I could use in the next step. So step 1, I'm going to find x. So the angle given is 70, x is opposite, and I have the hypotenuse 2. So I pick my ratio, which is sine. The angle given is 70, the opposite side is x, and the hypotenuse is 2, and we're going to solve for x. So we'll cross multiply. 2 times sine 70, and we get a measure of 1.88. And now that I have that, I can then use the triangle on the right to find the measure of the slide, which we'll call, let's call this M. So on this side, I have the angle given 40. I have the opposite, which is 1.88, which I just found. The slide is the hypotenuse of that, so I'm using sine again. Fill in what I know, so I know the angle is 40. Opposite I just found as 1.88, and we're looking for the measure of the slide. If we cross multiply, we get 1.88 equals m times sine 40. So we will have to find the value of m by dividing. Get rid of that, put it over here. And then we can find that, just type that into the calculator. 1.88 divided by sine of 40 is 2.92. And that units given are meters, so we'll include those. So that's just an example of a multi-step where you might have to find one measurement in order to find the measurement that you are looking for. Okay, another type of question you might get with right angle trig is angle of elevation and angle of depression. So just to clarify, angle of elevation is from the horizontal up. So here's the horizontal, and we would be looking up. The angle of depression is always from the horizontal looking down. So we generally have no issue with angle of elevation, but angle of depression, we just have to remember it's from the horizontal looking down. So in this example, we have a plane flying back from the Bahamas. It has an altitude of 10,000 feet over Lake Ontario. So this is 10,000 feet, and then this line at the bottom is the lake. So the altitude is 10,000. It is headed towards the airport. It just started its descent, and the angle of depression to the airport is 7 degrees. So here's the airport. Here's the plane. It's descending to the airport. It says the angle of elevation, which is always measured from the horizontal down, is 7 degrees. And it wants to find the distance to the airport. So that would be the distance from here. We'll just call this B to A. So the thing to remember with angle of depression is that we have two parallel lines. This line here is parallel to this because they are both horizontals. And so we can use, if you remember from grade 9, our Z pattern. If two lines are horizontal, then this angle is equal to this. So if this is 7 degrees, then so is this angle. And so now, and I have a right angle triangle, so now I can find x because I have the angle in this triangle. I have the height 10,000 and I have the adjacent side. So I'm going to use tan of 7 degrees. Well, we're going to use the tan ratio, so let's write it out. Opposite over adjacent. So the angle given 7, the opposite is 10,000, the adjacent is x. So if we cross multiply, we get x tan 7, so let's divide by tan 7 to get our result. And it works out to be 81,443. And this is in feet. So that's just angle of elevation, angle of depression. Okay, then we get into oblique triangles. So this means that we might not have a right angle. So we have no right angle. So then we are going to be using law of sines and law of cosines. So law of sines says the measure of a side and the sine of its angle is always in the same ratio. So we have a non-right angle triangle. Let's call it ABC. Remember that the side opposite the angle is always the same letter, but in lowercase. So if this is angle A, across from it is side A. If this is angle B, across from it is side B. And if this is angle C, across from it is side C. And so we can only use sine law when we have what is called a complete ratio. That means that you must have a side and its angle, at least one ratio, in order to use sine. If you don't have that, you can't use it. So we'll look at some examples on that. Cosine law, so same non-right angle triangle. Cosine law, we have two situations. We either have a contained angle, and what a contained angle is an angle between two sides. So for example, maybe we have this triangle here. We know this angle, and then we know the two sides. So you can't use sine law with a contained angle because you have an angle but no side. So this 30 degrees, I don't know the side opposite. The side 8, I don't know the angle opposite, and side 10, I don't know the angle opposite. So I don't have a complete ratio. I don't have a side and its angle. So I can't use law of sines. I have to use law of cosines. The other situation you'll use law of cosines is if you have all three sides. So all three sides, we might have something like this. So we have no complete ratio because we have a side, but we don't have the angles. So those are the two situations you would use cosine law, and then sine law you would use when you have a complete ratio. So the sort of checklist when you're doing trig is, sometimes you'll see this, if you have a right angle triangle, then you're going to use SOHCAHTOA. Right, you're going to use any of the three ratios. If you don't, then you can use law of sines or law of cosines. So right angle is your first checkpoint. If I have a right angle, I use SOHCAHTOA. If I don't, I'm going to check for law of sines, law of cosines. If I want to use law of sines, I have to have a complete ratio. Oops. Let's write that again. So law of sines, I need a complete ratio. And then law of cosines, I either need a contained angle or all three sides. So that's sort of my checklist. Okay, so here's an example. Find the length of side B. So side B is across from angle B. So I'm going to use this ratio. And I have the angle. Do I have another complete ratio? Yes, I do. I have angle A and I have side A. So this tells me I can use law of sines because I have a complete ratio where I know angle A and side A. So I know I'm going to use the complete ratio A and sine A, and I'm looking for B, so I'm going to use that ratio. I don't need C because I don't have any information about C. So I'll pick the law of sines, I'll pick the ratios that I'm using, and I'll fill in the information that I'm given. So I know side A, I know angle A, I know I'm looking for side B, and I know angle B. And then we're just going to cross multiply. So we're going to multiply these two together, these two. So we would have B times sine 71 equals 9.8 times sine 51, and then we want to isolate for B, so we'll divide by sine 71 to find our answer. And so B will be 9.8 times sine 51, and then we'll divide that answer by sine 71, and we get 8.1. So it's pretty easy, not too hard. In the next example, we have this complete ratio. We have, let's label this. So we'll call this A, B, C. So we have angle A and side A. So we do have a complete ratio. In this question, we're looking for angle B, and we have side B. So the complete ratio we have is A sine A. The ratio we're looking for is B sine B. So what do we know? We know side A is 12. We know angle A is 67. We know side B, and we're looking for angle B. So let's cross multiply. So 13 sine 67 is going to equal 12 sine B. Multiply these two together. We're looking to isolate for B, so we'll divide by 12. That equals sine B. So keep in mind that we're looking for the angle, so we're going to have to use the inverse of this calculation. So we're going to do 13 times sine 67 divided by 12, and then we'll do the inverse of that answer to find the angle. So I do get a decimal. I would suggest you just leave all these numbers in the calculator, but if you want to change to a decimal and then find the inverse, make sure you use 2 or 4 decimal places so that you get a more accurate answer. And my measurement works out to be approximately 86 degrees. Okay, in this example, we want to find the length of side X. So it looks like I don't have a complete ratio because I don't know the angle across from X, but I do know 2 of the angles. So I could find that missing angle by taking the sum of the angles of a triangle, which is 180, subtract the 2 that I'm given to find that missing angle. So sometimes it looks like you might not have a complete ratio, but you actually do because you know 2 of the angles. So if I know 2 of the angles, I can find that third angle. So that is actually 57. So let's label this A, B, C. So I'm looking for side C, and I know angle C. The complete ratio I have is A and sine A. So C is X, angle C is 57, side A is 44, angle A is 88. And so X will equal 44 times sine 57, and then we'll divide that by sine 88. So sometimes you do have enough information, you just might need to figure it out by subtracting from 180. So X works out to be approximately 36.9, and the units are given as millimeters. Okay, in this example, let's see if we have a complete ratio. So we are looking for X and we have the opposite angle, but we don't have another complete ratio. We have 22, but no angle. We have 17, but no angle. So we don't have a complete ratio. So we're going to use cosine law. And the reason we're using cosine law is because we have a contained angle. So cosine law, I'm going to call this A, B, C. Cosine law, we have a formula for a missing side. And it's always the same pattern. And this is on your formula sheet, but if I want a side, I take the side I want, which is A, in this case. It's square of the other 2 sides minus 2 times the other 2 sides, and then cosine of the angle that I'm given. If I am looking for a missing angle, I could rearrange this formula. So let's say I wanted angle A. So cosine A would equal A squared. Sorry. Let's erase that. If we have a missing angle, it's going to be the square of the other 2 sides minus that side divided by 2BC. So these formulas are on your formula sheet. You just have to select the appropriate one, whether you're looking for a missing side or a missing angle. So in this question, we're looking for a missing side A. All right, so this is across from angle A. So the other 2 sides, B is 22 across from angle B. C is 17 across from angle C. Then we've got 2 times 22 times 17, and then cosine of the angle given, angle A, which is 42. So you can type it all into your calculator if you want, or you can do it separately. If you do it separately, so I'm just going to show you that. I'm going to square 22. I'm going to square 17. And then I have to make sure that I do all of this as one number. I don't want to separate it. I want it as one number. So I'm going to do 2 times 22 times 17 times cosine 42 and get one number. Or like I said, you could type it all into the calculator at once. So A squared is equal to 217.1277, and then I want a square root because I want A So I'm going to square root my answer. And it works out to be 14.7. In this example, we want the measure of a missing angle. So let's again label letters. Just call it A, B, C. I want angle A. So it's going to be cosine of A is the other two sides squared minus A over 2 times the other two sides. So B is across from angle B, that's 39. C is across from angle C, so that's 47. And A is 35. And so I'm going to determine the numerator. That's 2505. I'm going to determine the denominator is 3666. And then we want angle A, so we will do the inverse. Every time we're looking for the angle, we always have to do the inverse. And so angle A will be equal to approximately 47 degrees. So try that on your calculator and make sure that you can get that correct calculation. Okay, the last thing we want to look at is the law of signs, the ambiguous case. So what does that mean? Well, ambiguous means that something is unclear or not exact. It means it's not exactly one answer or one interpretation. So for example, if I typed in sine 30 on my calculator, I get a value of 0.5. If I typed in sine 150 on my calculator, I also get a value of 0.5. So the ratio of sine 30 and sine 150 are the same. So 150 would be over here. So if let's move this over, if I measured 150, that would be over here. Well, 150 creates the same angle if I connect to the x-axis. So that's why we get the same ratio, because 30 in quadrant 1 is going to give me the same answer in quadrant 2, because 180 minus 150 is also 30. And it would be the same as, so these are supplementary angles. We would have talked about supplementary angles in grade 9. So supplementary angles are 30 and then 180. So supplementary means they add to 180. So 180 minus 30 is 150. That's why we're getting the same answer. The same with sine 64 and sine 116. They are supplementary. So if I typed in sine 64, I get 0.898. And if I typed in sine 116, I also get 0.898. And that's because 64 and 116 are supplementary. 180 minus 64 is 116. So that comes into play with the ambiguous case of the law of signs. If we have a triangle, depending on the measure of this third side, you can see in example 1, that side is not long enough, so I can't make a triangle. So what you're given in common is this side, and this angle. So you've got 3 scenarios. Okay, so the bottom side and the angle and the second side are all the same. The third side is what we're looking at. So if that third side is not long enough, we can't make a triangle. In case 2, it'll be exactly long enough, and it will make one triangle. In case 3, it might be able to fit this way and make a triangle, or this way. We could put it in 2 separate positions and get 2 different triangles. So we might get a triangle that looks like this, or we might get a triangle that looks like this, which is acute. So this angle would be an obtuse angle, and this angle would be, that third angle would be an acute angle. So we can actually make 2 different triangles with the same measurements, where one angle is acute and one is obtuse. So how do we know which one do we have? So the steps to follow are, you're going to find the missing angle just using law of sines like you always do. If you get error when you are trying to find it, then you don't have a triangle, you'd have case 1. So if you try to find that missing angle and you get error on your calculator, it means that you can't make a triangle with those measurements. If you get an answer, you're then going to find the supplementary angle. And then we're going to check. If we take the supplementary plus the given and it's more than 180, you only have one triangle. If you take the supplementary and the given angle, which is less than 180, you could have two possible triangles. So that's the steps that we're going to look at. So let's look at example 1. We want the measure of angle B. So the complete ratio we have is A sine A, and we're looking for B sine B. So A is 5, angle A is 42, B is 10, and we're looking for angle B. So we're just solving trig, or law of sines, like we always do. We're going to cross multiply. So 10 sine 42, we're going to divide by 5, and that will give us the sine of B. And so let's try this on our calculator. So we're going to do 10 sine 42, we're going to divide that by 5, and we get 1.338. And if we try to do that on our calculator, we'll get error. And that's because the ratio is bigger than 1. If the ratio is bigger than 1, you're always going to get error. So we get error. What does that tell us? That means that we can't make this triangle with these measurements. That means there is no triangle with these measurements that would be able to be constructed. So that is case 1. If you get error, there is no triangle. Let's look at the second example. So we want the measure of angle C. So we're going to use C sine C. We have a complete ratio A, so we're going to use A sine A. So C is 13. We're looking for angle C. A is 15. We're looking for... So let's cross multiply and divide. So we've got 13 times sine 41 over 15. So let's see what we get here. So if we change that to a decimal, and then we'll find angle C. So we're able to find angle C because the ratio is less than 1. And so angle C is 35. So now we're going to check. We're going to find the supplementary angle to angle C. So 180 minus 35 will give us the supplementary angle, which is 145. Then we're going to check. So we're going to take the supplementary plus the angle that was given to find that third angle. So supplementary is 145. The angle given was 41, right? That's the angle given. So that gives us 186. 186 is bigger than 180, which means that's too big. So that means there's only one triangle. There's only one answer. So that means there's only one triangle because the supplementary plus the given would be more than 180, which means it's too big. That supplementary answer would be too big to make a triangle. So we only have one answer, which would be the one that we found. So that means angle A given was 41. We found C to be 35, and then we could find B by just subtracting from 180, and that's 104. So those are my three angles. I only have one triangle with those three angles. Okay, let's look at this one. So we're going to do law of sines as we always do. We're looking for B. So we're going to use B over sine B, and we're going to use A over sine A because we have that complete ratio. So B is 20. We're looking for angle B. So sine of b will be, let's cross multiply 20 times sine 30, and then divided by 15, and then we'll find the inverse of this. And it's 0.6667, which is not greater than 1, so we should be able to find the answer for angle B. So we'll do shift sign of the answer, and we get approximately 42. Then we're going to find the supplementary to B that we just found. So it'll be 180 minus 42, which is 138. And then we're going to take the supplementary plus the one that was given. So 138 plus the angle given was 30, which is 168, which is less than 180, which tells us that there is two possible triangles for this question. So what are those two triangles? Well, case 1 would be the angle given as 30, and then the answer that we found as B. Right? This is what we found B to be. So the first triangle would be the angle given 30, the angle that we found 42, and that third angle would be 180 minus 36 minus 42. So 102. So that's case 1. Case 2 would be the angle given, because that's not going to change, and then the supplementary to B. So the supplementary to B was 138. And then the third angle, so I'll just write that in here. This is the supplementary. And so the third angle would then be 180 minus 30 minus 138 is 12. So that would be the second triangle that would be able to be constructed with that third angle being the supplementary. So whenever you have law of sines, you always just want to double check to make sure it's not the ambiguous case. So you would solve law of sines as you always do, and then you're just going to subtract your answer to find the supplementary and check and see if your supplementary plus your given is not more or less than 180. If it's more than 180, you know you only have one answer. If it's less than 180, you know that you could have two possible answers.